So this is going to be the last video before your exam. In this video I'm going to go through and do shorthand truth tables for the truth tables that otherwise you would have to use longer truth tables for to find validity. This is going to be for validity and invalidity. I'm going to show you a number of ones that are invalid arguments, and I'm also going to show you what happens if you have a valid argument. Valid arguments can be complex, but if you try to solve them in the wrong way using shorthand truth tables, you'll accidentally think that they're invalid. Let's start with some that we know that are invalid. So let's try to show that P and Q arrow R, therefore P arrow R is invalid. So we want a value for P, a value for Q, and a value for R such that all the premises are true, but the conclusion is false. Let's go ahead and assign the values we want to everything. So we want the premise to be false, and we want the conclusion to be false, and we want the premise to be true. In order for this premise to be false, P would have to be true and R would have to be false, just in virtue of how arrows work. So we can fill in our value for P and we can fill in our value for R. At least right now we can. Then when we hop over to the premises, we would want to fill in the value such that we can say, hey, let's see if stuff works. So we would want to fill in the value for P as T, the value for R as F, and we would want to ask now, what would we want this overall arrow statement to be? If we know that we have F as the consequent, but we want a true conclude or a true premise, we know that the antecedent, the P and Q, would have to end up being false. So what makes P and something false? Well, in this case, what makes it false is if you have a F as Q. And now we need to double check it. So we say T and F, arrow F, therefore T arrow F. And then we check. Is T arrow F false? Yes. What's T and F? This is false. What's F arrow F? It's true. So this shows us that this argument is invalid using these assignments for truth value. Let's look at another one. Let's say that we had P arrow Q or R, therefore P arrow Q. We do the same thing we did last time. We go ahead and assign values given what we want it to be. We want P arrow Q to be false. We want P arrow Q or R to be true. And then for the conclusion, we know that P will be T and Q will be F, because we want the arrow to come out being overall false. Start our bank, go ahead and start filling in. P equals T, Q equals F. Now let's go ahead and contingently fill in some things over here. Let's assume that P is true on this side. Let's assume that Q is false on this side. Notice that what we have here is we want this arrow to be true. If we already have a true antecedent, we don't want a false consequent. Since Q is already false, we want the disjunct here to be true. So what would R have to be? Well, it'd probably have to be true. And then let's check. T arrow F or T, therefore T arrow F. That's false. It's what we want. This is true, which gives us T arrow T, which is true. So this works, and R equaling T gives us the values that we need to make this argument invalid. Let's try another one. Let's say that we had P arrow Q, P arrow R, therefore Q arrow R. We fill in the values for what we want. We want the conclusion to be false. We want the premises to be true. We know that if a conclusion is false and that conclusion has an arrow, the antecedent must be true and the consequent must be false. So R here we're saying hypothetically is going to be false. Q we're going to assign the value of true. And then we're going to plug these values in on the left side just to see what would happen. And R is false. And now we can start asking. So for P in the first premise here, we actually can't tell what P would have to be since F arrow T is true and T arrow T is true. But in premise 2 right here, if we want that premise to be true and we have a false consequent, we know that the antecedent must be true. And then we can double check it and fill it in. T arrow T, comma, T. Oh, actually I already made a mistake. We don't want that to be true. What we want it to be is false, because false arrow false is true. And then we fill it in. F arrow T, F arrow F, therefore T arrow F. This is false, this is true, that's true. So this is our value such that the argument is invalid. Let's say that we had P arrow R, Q arrow R, therefore P arrow Q. Again, we assign the values that we want it to have ultimately. False conclusion, true premises. We fill in the values we can figure out. We know that P must be true and Q must be false to make the conclusion false, since the conclusion is an arrow. We fill in the values that we've assumed for P and assumed for Q on the left side over in the premises, so true and false. We ask, what would R have to be to make this first premise stay true? Well, it can't be false. That would make the premise false. It has to be true. Fill it in, and then we double check. T arrow T, F arrow T, therefore T arrow F. This is false. That's true. That's true. So if P equals T, Q equals F, and R equals T, these are the values that make this argument invalid. So let's figure out now what would happen if we had an argument that was actually valid. So let's take a look at some arguments that we know, matter of fact, are valid, and figure out what the truth value would end up looking like. So let's say that I gave you the following. Let's say that I gave you, I'm looking through a few things here just to see what would work. Let's do this one. So let's say that I gave you not P, P or Q, therefore Q. We'd assign the values we think that we already know. We want a false conclusion, and we want all true premises. So Q right now we're going to suppose equals false. We can assume over here it's P. If negation P is true, that means that P itself must be false. So let's plug in values here. False, and then we already know that Q is false because it's false in the conclusion. But now let's double check. Not F, F or F, therefore F. Here the conclusion is false, that's what we want. Not F is true, that's what we want. But F or F isn't true, it's false. So what we can see here is if we try to invalidate a valid argument using the shorthand truth tables, we run into a type of contradiction. In order for all the premises to be true, Q's value would actually have to be true here. But if Q was true in the premises, it would also end up being true in the conclusion, and that would give us either all true premises and a true conclusion, or if we really wanted Q to be false, we would have a false premise in order to have a false conclusion. So there isn't a set value here that would allow us to get all true premises and a false conclusion for a valid argument. So let's look at another few of these just to see how they work. So let's say that I had something like this. P, Q, P and Q arrow R, therefore R. Go through, assign the values you think you might know that you want. R would be false. P over here would be true because we want true premises. Q would be true because we want true premises. And the operator of the arrow would be true. Now let's see what happens when we start filling in those blanks, filling in those values. R is false because we said it's false in the conclusion. P is true and Q is true. And we filled in everything, but now let's double check it. T, 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 and T, arrow F, therefore F. So this one works for that. It works for that premise, it works for that premise, but T and T is T. T arrow F is false. So in order to have all true premises here, what we would have to have is Q or something to be a value that it's not. Or actually, in this case, it would be R. So if we want all true premises and a false conclusion, we have an option. Here we either end up with all true premises and a true conclusion, or, so like let me demo that one. In order to get all true premises to begin with, we would need T, T, and T. In order for T and T arrow F to be true, R would have to actually be true instead. But if R is true, it's also true in the conclusion. So let's say that we really want R to be false. Well, we could make this one true and this one true, but this premise ends up false. So these are our two options. Either we end up with all true premises and a true conclusion, or a false conclusion, but at least one false premise. And this is a trend that you will see with every truth table that you, or every abbreviated truth table that you do. If it's a valid argument, it's impossible to make a set of premises and conclusions such that you can have all true premises and a false conclusion at the same time. Let me do one more. Let's say that I had P and Q arrow, P or Q arrow R or S, P, Q, not S, therefore R. Go through, assign the values that you can already know. R, if we want to be false, would have to be false. Then we assign true to the main operators of each of the other premises. Then we're going to go through, we're going to assign other things as we can. So negation S, if negation S is true, that means S is actually false. Then we're going to slot in the values. So P we already determined is true, Q we've determined is true, R we've determined is false, and S we've determined is false. And now we get to go through and check to see whether or not it works. So T and T, arrow, F or F, comma, T, comma, T, not F, therefore F. Here we have a false conclusion, but let's check everything else. We also have, so we have a true premise here, not F ends up being true. That's true. But let's figure out this stuff. So T and T is true. Therefore, F or F, though, is false. So we have a T arrow F, and that would make this premise false. In the event that we wanted to make this into a true premise, what would have to happen is as follows. One of these pieces would have to have been true. However, if we make S true, for example, so let's say that we decide that we wanted to make S true instead, it would turn out true over here, but not T is F. So then we would still, in this case, not have all true premises and a false conclusion. We would have at least one false premise. So let's assume that we did something different. Let's say instead that I made R true. Well, if R is true over here, it would have to be true over in the conclusion. But in that case, we don't have all true premises and a false conclusion. We have all true premises, but a true conclusion. So what this tells us is, again, that there is no value for P, Q, R, and S such that we can have all true premises and a false conclusion. So the argument must be valid.